Well, hi, good morning, and thank you so much for joining me in my shop here. Today is the 15th of October, and the radio you see before you is still not operating, even though I poked around with it last night here for a while. At the end of the last video, I was suspicious that the muting system may be in trouble, and the radio may be muting itself when it shouldn't. So I pursued that idea last night, mostly just learning the location of things in the radio and a little bit about the circuitry. And I did one or two tests on it, and nothing conclusive at all. So today we want to go a little further with examining the system which, nulls out the sound. Its operation is kind of simple in a way. There's a complicated way in which this light is turned on and off. When it's off, it indicates that the synthesizer up here is adjusted properly. When the light is on, it indicates the synthesizer is running, I don't want to say in a random way. I don't know. I just noticed something odd about this radio. A little bit of bad planning in the design. They had to cut slots through here for these pieces to stick out. I gotta guess that's a design error of some sort. I don't know. I got all that way and went, oh my god, look what we've done. What are we gonna do now? Cut slots. When the light is on, and that means the synthesizer is not matched up with a particular frequency, the voltage that's driving this light is utilized in the I forgot the word for crying out loud. The nulling of the sound, muting. How could I forget that word? Muting of the sound. So this functions perfectly fine. The light comes on and off as you would want. It all seems to make sense. And for quite a while there, the radio was operating properly, muting and unmuting in accordance with the position of the light. But no longer, if it's a muting thing. Okay, we don't know for sure that it's a muting thing. Now, how does a radio mute it? I would have thought they would mute it by doing something in the audio circuits that would cut it off. But they don't. They actually mute it part way, or maybe even the early stages of the 230 kilocycle IF circuit, the final IF in this radio. And they have a way of fiddling with collector voltage on one of the transistors involved in the 230 kilohertz IF. And this is what mutes the radio. So it actually cuts the radio off quite early. Well, in this radio it's not early, it's actually late. But they cut it way ahead of the audio, somewhere in one of the IF strings. So a little surprised to learn that, but and the way they do this is they alter, I believe it's the emitter voltage of one of the IF amplifier transistors enough that it stops operating. And from what I've read, that's the difference between 12 and 11 volts, which, okay, this makes me very uncomfortable. The difference, in my world of vacuum tube radios, the difference between 12 and 11 volts, there is no difference. But in these things, the whole voltage range is just 12 volts. So, I have to get used to the idea that there are voltages, different levels that are required to make this thing operate. So changing it from 12 to 11 or below 11, maybe it has to go a little bit below 11, cuts off that transistor. Now my transistor knowledge is so rusty, I studied it all in college, but that was a while ago, and I've done almost nothing with transistors since then. So my impression of it, without studying it and sort of reminding myself about how the whole thing works, and I don't want to say anything more than that because I'm probably wrong anyway, and it really doesn't matter. So it's just affecting this little voltage on this transistor, which is up in this area here. No, it's down in this area here. It's derived from another I was going to say transistor, but it's a transistor that's been wired as a diode, kind of like that. And the idea is, I think when you forward bias this transistor diode, you then allow the passage of a heavy current, which causes a voltage drop, which drops the emitter voltage up here from where it is to below 11. Something like that is taking place, or supposed to take place. Now, some of these voltages are presented on the back of this radio in this very handy connector. And many terminals in it, and many voltages provided there to look at, including 2 related to this whole system. We're going to take a look at the schematic next, and then I'm going to repeat some of the tests I did yesterday evening, and then we're going to try to pursue it another step further forward and find out if the 230IF really is being muted. If the 230IF is being muted, then the problem is the mute system. And that's, in this great big complicated radio, it's just a little tiny area down here that's really potentially in trouble. So let's start by taking a look at the schematic, and maybe I'll go get some coffee in the meantime. Ooh, that's a good idea. Okay, so here's a look at the entire schematic for this radio. And the part we're interested in, the area we're interested in, is just down here. So I'm going to zoom in on that area and do my best to explain how it operates, and don't anybody listen to me carefully, because I probably don't have it quite right. So what's happening here is when the synthesizer is not tuned, so the red light is on, a positive voltage develops here because of this diode and the way the signal is being presented into the circuit. So the positive voltage here, this is where things are going to get difficult for me, results in a heavy current flow, or turns on this transistor, or increases its current flow, causing a pretty good voltage drop here from the 12 volt supply. So this guy normally has 12 volts or so on the base, and when this guy starts operating, it drops. When it drops, and this, I don't understand this fully, so I probably got this mixed up, but generally speaking, what I'm telling you is correct. Specifically, probably not. So, so when this guy operates, and current begins to flow, and this light comes on. And this happens when the hey, a little slow this morning. Synthesizer light is on. So synthesizer light is on. We do not want to hear anything from the radio. It's not ready for listening to. So in the same way, this transistor gets turned on and this light comes on, this transistor gets turned on. When this one gets turned on, it pulls the voltage of this line down. So the voltage here is going to be something a little less than 12, and with this guy operating, more current pulled through here, bigger voltage drop, this guy goes down. Where's this guy going? He's going to the third 230 kilocycle IF amplifier, transistor number 14. So this is I when I look at stuff like this, I think, wow, how did they ever come up with this? But I guess like this, they were blazing a trail here. I believe the engineers designing this radio were pretty much blazing a trail using the newfangled transistors and trying to replicate the experience of the earlier tube type HRO radio. This is where it got them. It got them all the way to here. It's the band changing thing that is so difficult on a band spread where the 500 kilohertz is spread over 10 or 12 feet of dial. That's really tricky to do with coils and capacitors, so they've come up with this very clever synthesizer technique to generate local oscillator frequencies and other stuff in the radio. Okay, getting back to this, because I'm rambling now. And again, I just have kind of a smoky, foggy feeling about how all this works. So you don't have a tight grip on it. So So by dropping, we can read this in the written part. It actually says something about the voltage here dropping below 11 volts. And when it gets below 11 volts, the amplifier Q14 shuts off. That cuts off the output of the IF. There's nothing left for the radio to produce in the speaker. I want to prove this is happening. Now, before I go directly on this, because these things are hard to access in the radio, they're a little dangerous too, trying to put leads in and catch places to make tests. Some of these voltages are presented on that big connector at the back of the radio. So here's one. The connector's number is J14, and this would be position 12 on that connector. Is this? Why, it's the base going right into this muting transistor. So we can look at the base voltage of this muting transistor, operate the radio, do stuff, and watch it go up and down or whatever. And then again, there's another spot over here, where again, on that connector, the J14 connector, in position 13, there's another opportunity to make tests, or in fact, they're inviting you to utilize this as a place to mute the radio, if you want. You can stick 12 volts on here and the radio's muted. Or is it 12 volts on here and the radio's muted? I can't remember now. I think it's this one. It's this one you ground, and no, I think you can ground this one, or you put 12 volts on this one way or the other. You can play around with muting this radio externally. So maybe that would work with some other equipment, like a transmitter or something. You can mute the radio when you transmit. I don't really know. But in any case, we can put a voltmeter, or I put a scope on this, and we can watch what's happening in this location when the radio's operating, and get a feel for what's up, what's down, and who's going where. Just a couple more observations before I leave the schematic. This capacitor is an electrolytic capacitor, and we all know electrolytic capacitors of this age have big question marks after them. And there's another one down here. So, if either of these are acting up, maybe that would cause a disruption in the operation of the circuit. The fact is, this light operates exactly as you would want. It looks like that whole circuit that synthesizes the frequency is all working right. So you could conclude from that if this is working right, this is working right, this is working right, everything's working right, what's left out? This guy's left out, this capacitor's left out, this resistor's left out, and Q14 itself, and other potential problems. For all I know, I'm barking up the wrong tree here. Don't think so. So I just want to find out, is this the right tree to bark at, or should I be barking at another tree? So to do that, as like I said, I'm going to repeat the tests I did last night, do a little better job on them. We'll look at the voltage here and the voltage here. We'll operate the radio, fool around with it, and just see what we can derive from these two readings. Okay, bit of a crazy pile of stuff on the screen there. So you see my dual trace scope with two traces on it, and so this, I don't know which is which just yet, but we'll figure it out quickly. But this is one connection on the back of the J connector, and this is the yellow one, the two outputs I showed you on the schematic. So we can watch each one of them operate, whatever they're going to do. This is on DC, this is on DC, both on 1 volt right now. Let's see, what else have I got? So I've got my SDR going. You see it up in the top left there, and it's hooked up to this coil, which I'm going to interfere with here and make sure it's working. Well, it doesn't show much response, does it? But it does respond a little bit, so it's definitely working. I have the pickup coil probe right where I believe the 230 kilohertz signal is, or could be. Now, this is not the best way to do this, just a way. We're going to try first and see what happens here. See if I can rotate this out of the way a little bit. So we can see the front of the radio. Maybe we can let it back up a little bit here. Okay, so keeping your eye on the red light is quite important during this experiment. Red light goes on and off. The muting should be going on and off at the same time. I do have this hooked up to a speaker. It is hooked up to an antenna. I think the antenna is even turned on. So if it starts working, and it may start working, who knows? We'll hear it. We'll know it as long as I keep the audio turned up here. Maybe I should. I'm going to stop and just rearrange my screen just a touch here. Okay, I think this is going to work a little better. So 230 kilohertz is right in the middle of the SDR screen, and I have the SDR tuning indicator right on top of it. So that's the area we're looking in. What that thing is out at 300 kilohertz, curious, but I got no idea. This isn't even on. Okay, I think we're ready to start. So just double checking the settings here and turning the volume down just in case. You never know. Okay, we'll turn the power on to the power. And now we'll turn the power on. And I don't think I have the cord connected at the back. And one of my test probes has fallen out. Hang on a sec here. Yeah, I had all this set up so I wouldn't get caught in the middle of this kind of thing. Okay, so I get very turned around looking at this diagram. So we want to go. Yeah, you weren't supposed to watch stuff like this. Maybe I didn't get enough sleep last night. I don't know what happened to me here. So it should be third. Should be this one here. Okay, stay put now. If it's wrong, we'll figure it out pretty quick. Okay, and I'm now going to attach the power. Let me see if this is off. Attach the power. Mistake with that. Okay, we're ready now. What happened? It's not coming on. This is on. The ground is off. The ground is off. That's right. That's right. They took the ground off last night when I tipped the setup on its side. Okay, we're gonna get there. We're gonna get there. So I'm gonna attach the ground like that. This time it's gonna come on. Okay, watching everything. Interesting stuff on the scope there. So you can see the two voltages have gone somewhere. They didn't stay at zero. I'll change the scale on the upper one here. Bring it back in view. I cannot get it in view, so we'll have to just bring it down. We're going to put this on ground to find out where the zero is now. Well, the zero is right on the zero. Okay, so we can make a reading of voltage here. 5 volts per division. Ooh, what happened there? What's happening? I'm going to leave this just the way it is and pay more attention to the 230 output. Is the light on? The light is off. So the radio is theoretically unmuted. Wouldn't it be something if we suddenly heard something? But we got to be very careful here. All the ducts have to be lined up. So we are currently at 6 megahertz, not a good place to be at this time of day. And the light is out. And what of it? Pre-select tuning is the you can watch this meter here, because the meter is always reflecting actual signals coming in. Not there, here. So I'm watching this meter, which you may not be able to see. And we're not going to get anywhere with 9. The 6 rather. We need to be up on a higher frequency, like the 9.3. Let's go up there. You can watch the light operate, and you can see what's going on the scope. Okay, I'll slow down. Both voltages are traveling. Now they're both, yeah, they're kind of a reflection of each other in a way. One is kind of driving the other. I think you can think of it that way. Looks like it's operating just fine, doesn't it? And where are we? We're at 8. We want to go up to 9.5. This is 9. Okay, the thing about being here is we should be able to see a response on the meter when I get this guy around 9.3. Only because I believe there's a station there. Somewhere in here. I don't see anything happening. Oh, pre-selector tune. Oh, I already did that. I bet you the antenna's switched off. Okay, so I'm gonna leave all this running and the video going too. I'm gonna run and throw the switch. Okay, turns out antenna is switched on. So why are we not getting any response on the meter there? Oh, we did. It is going up. So I found if you set the AGC threshold off, you get, I mean, you don't have any AGC action theoretically. And we should see it's just a little tiny bump. It's almost nothing. Okay, let's do this. Aha! Ah, this is so sharp. Trying to tune a sharp control on a fading signal. Pretty challenging, but now we do have a signal, 9.33. So this is the this is a shortwave station that's almost always there. Okay, now can we hear anything? We don't hear a thing. So my thinking is this guy is muted. And if he's muted, we won't see a 230 signal. So we now turn our attention to the SDR, and there's just absolutely nothing at 230. Now the question is, oh, there is a little something there. There's a little something right here. Just yeah. Let's just keep an eye on that little tiny bump there, which is fading up and down, which isn't good. Well, maybe it is part of maybe it follows this. The radio is not muted. We'll now cause the muting and we'll see what happens to the 230, the little tiny 230 there. Okay, I can see on the scope we're muted, and there's still some stuff bopping up and down, but now I'm going to go back until, okay, we're back. There it is again. So I'm picking up the 230, probably got the pickup coil in a weak spot. So if we move this around, we probably get a much bigger, bigger response if I just get it in the right area. Okay, so call that the right area. Can you stay there, please? Okay, so there's a fairly good view of the 230. The 230 should be there when the light is out. When the light is on, the 230 should go away. And it went away. So what this means is the muting circuit is working as intended. So come back again. So I'm barking up the wrong tree. That's what this is telling me. Somehow the 230 signal is not making it out. We can listen to this signal, by the way. We can use the SDR to decode it. Let me just get it right on the money here. Did you hear it? Can you hear it? There's a voice in there. Well, if you couldn't hear it, I could. So there's tuned program material making it all the way through the 230 something after that. Something after that is causing the loss of audio. Okay, well, at least I've proven it's not what I thought it was. Now I got to move on to something else, some other theory. I guess if we know the signal is in the 230 IF, we don't know what's coming out. It could be getting partway through. Where does the muting take place? At the end or at the start? Let's take a look at the schematic here. I think I can just pop it up on the screen, can I not? I think I can. Bingo. So, and what did I just say? I want to look at the transistor that's being muted. So here it says 2Q14. I'll zoom in when I get there. So, okay, Q14. Found this last night after a fair bit of searching in the 230. You know, I don't remember where it is now. Q14. Oh, I'm going to be hunting around here forever. Q9. No, not way up there. Yeah, I apologize for this. Hunt, it's so small on your screen. Let me, yeah, it's so small on your screen. Q14. There it is. Okay, so we're going to zoom in on this guy. Let me put him kind of in the middle. And then we'll zoom up. Whoa, where'd he go? Q14 right here. Here it says Q16 muting, so this is where the muting voltage is being manipulated in the other circuit we were looking at, and this is the transistor, and this is the third IF amplifier. Here's the second, and the first is probably off the screen, and the result of this is we are muting it at the last stage, which means what we see on the scope is representative of what's actually coming out of this circuit, which is nothing when it's muted, which again just indicates everything is working properly. So where does it go after this? So this will be my evening project, to understand where the signal is going out of here. It goes into two detectors. There's a product detector, or there's also an AM detector. If I change detectors, does it change? I don't think so, because I did that before. We're going to do it again in a moment. And then from there, look, there's a 230 kilohertz output on the back of the radio, which I could hook into my SDR and start using this radio again. I could actually do that. I can actually run an SDR off of this. Just tune the SDR to 230 and there you are. Well, that's interesting too. That's a shortcut to get out of this mess if I can't solve it. Or is it really there? Is it even really there? We should take a look at that. What kind of output is this? Can I just hook my SDR right up to that and let it blast into the SDR? Probably not. Could do something though. Do some kind of loose coupling here for fear. How is this isolated? Wait, it's that's a tap on this coil, so it's not really isolated. There isn't even a capacitor in here. I'll be a little bit careful with this, because you know you could hook up a piece of test equipment, find nothing, but it's really the test equipment that's causing the nothing. When you remove the test equipment, the situation reverts back to normal. That can be very, very confusing. So a little hesitant on doing that. That's possible to do that though. So let's flip detectors and we'll see what happens here. Oh, you're looking at the whole I'm sorry, I forgot you were looking at a small screen. That's okay though. Okay, we're going to change detectors. The volume is full. That's probably not a good idea. Okay, so we just flip this knob, watching everything. Wait a minute. Yeah, we're on. We're on. And how strong is the signal? The signal's there. Not very strong though. Okay, switch it. So nothing happened in the audio. So the problem, well, it could be just ahead of both these detectors, or it could be after. ultimately both detectors lead into the audio. So there's probably a detector output on the back of this thing. Wouldn't they do that? Wouldn't they put a I don't know. Detector out right there. So I should look into this also tonight. I'll look into the detector out, what we can do with it. Maybe I'll look into it right now. Yeah, I'll go drink some coffee and think about this. There's some interesting opportunities to poke around. I like the poking around. Okay, so I got to the point. I'm still in the middle of trying to get this kind of set up and operating. And you see on the scope a signal that's coming from the detector output at the back of the radio. Can you hear the tone in the speaker? I can. I can hear a very faint tone. Gone. And there. What exactly the tone is, I don't know. Why would there be a tone there? Is it because I'm receiving it? Is that what I see on the scope? Let's tune. You can probably hear the pitch going up and down now. So nothing changing really on the scope. This is drifting up and down as I tune, but I'm not sure it's... So we're still on the single sideband, yeah? Let's see if we can do something a little better with... No, it shouldn't do anything. It shouldn't do anything. So as soon as you engage the AGC, it just drops out. The tone does. Nothing on the scope. Don't know what any of this means. Just poking around. If it changed bands. Ooh. That's interesting, but no tone. Because the tone is related to the tuning. I didn't even look. Did the light come on there? We're so close here. Okay, we'll go to the AM. So we can't hear it now. So there's a little bit of audio getting through. Oh. Oh, I didn't notice that. So we changed to AM. And this is the BFO. BFO. Is there a BFO? This is the BFO, isn't it? Passband tune. I don't hear any change. Okay, let's examine what we really got here. I'm going to flip the SDR back up on the screen. Should have probably had that on there the whole time. Hey, what's that other thing right beside the main peak? Oh, that's maybe the single sideband. The single, that's the single sideband. Is it? We'll go to AM. So I believe that's the that's a radio station. Wait a minute. How come it's moving around? Well, it's moving around in the 230 IF, which is normal. That would happen in any IF. It's fading, probably following the meter here quite nicely. I'm not really looking. So detector output. I would have thought that the reason I have that on the scope is because I haven't connected it to something we can listen to yet, like audio, because I wanted to see what it looked like on the scope first. So it's a very, very low signal. This is set very sensitive. There's next to nothing there. And it sure doesn't look like a program material at all. So at this point we could conclude the detector output is suggesting there's no output from the detector. And this localizes the problem very, very neatly. Very neatly. Let's just take a peek at that schematic again. Because we're seeing this as being turned on and off, and we see a 230 here on the SDR. And then just a short ways away here, am I doing the right thing here? No, I'm not on this. I'm on the detector output. Where's that? It's going to be listed in here somewhere. Well, who knows? Here we are. J1418. J1418. Is that it? J1418 detector output. In the corner. Right in the corner. I get this thing turned around so much. This guy, and I doubt every time I make a connection to it. Okay, we can put the 230 that I see on the scope. No, that's a detector output. We want to do this with the 230 output. Okay, so am I getting a little confused here? Sure. Why don't we use a capacitor to make it seem more safe? I'll grab one here. Very small capacitor. So we're going to put this into the 230 out, 230K out, which is well, where is it? AGC, detector out. Oh no, it's not on this. It's not on this. It's on. There's a whole bunch of phono jacks at the back. Oh, that's easy. Okay, so I'm gonna grab this. Slowly I turn. Remember that? Slowly I turn. Okay, so back here are a whole bunch of phono jacks on the back of this radio here. One of them is 230 output. So let me identify that. So we have it just says IF out. Doesn't say 230 IF out. Down here it says BFO out, VFO in, local frequency, LO frequency in. Well, it must be, isn't there another set up here? And these are more related to the antenna. So it's got to be this IF out. They didn't say 230 IF out. So I'm plugging in a cable here to nowhere. Does this interfere with the radio? Didn't seem to do anything to anything. Now I can connect this one lead here to my SDR antenna. And we better have the SDR on the screen, because if I blow it up, we would want to see that. We would want to see that happen. Okay, so we're looking for the 230. Hot diggity dog. There it is, all right, and it's pretty darn strong. So patting that down. Wait, want to stick a capacitor in there? Is that going to do it? I take this off here, and this is too big a capacitor. It's not going to pad anything down. All. It's just a little much for my SDR. Let me get a much smaller capacitor. I'm sure I've got some laying around here. I don't know if these are really much smaller. Hey, here's a guy. Here's a guy with a resistor on him. Beautiful. What is that? That's got an orange third band, so it's a K. So we would take the SDR. This is the SDR there. This is the output from the radio. Go here. Wow, that really cut it back, didn't? Oh no, I'm looking at the wrong thing. Beautiful. That's perfect. That's perfect. Okay, lovely. Now, we're going to cause the radio to mute and see that this disappears. So here we go. Mute that thing. Wow, it really disappears, doesn't it? And the red light must be on. We'll come back up. Fantastic. Oop, went a little too far. We are now going to listen to this signal using the SDR as our I'm tuning the radio. Now we are listening to the SDR, so the signal cuts off right on that gray edge, the gray edge there. That's the SDR. Got that. So now we know that this is working past the detector. Let's flip on the single sideband detector. And we'll vary the... I thought we would vary the... Where's the BFO frequency adjust? On here. Oh, it's got a thing called passband tuning. Doesn't it have a... well, I'm getting confused with other radios. Well, that's kind of weird. Usually there's a BFO adjustment, but maybe not on this radio. Okay, that's back to just AM. You can hear what sounded like a BFO. I'm sure there's a BFO in there. Well, okay, so now we've absolutely proved the radio is functioning just fine in pretty much all respects, right up until the output of the 230 IF. So we need to chase that down. I think that's for tomorrow because I want to study during the day today, study up and maybe do some experiments this evening and see if I can get this to come back. I mean, it's got to be something simple. It's really, it's a sad thing in a way. You have all this stuff working except for some little part. Yeah, and anyway, I'm going to try to find it. Thanks a lot for watching today. And who knows, maybe tomorrow I'll have this thing working. I'm feeling pretty hopeful now. See ya.